array. And so what this line there is doing is exactly that. It's opening the file call that's at that path and storing it inside of the DB pointer. All right, what's happening next? I'm selecting all words. So this is what I meant earlier about the expressiveness. This is a SQL query, and this file at the end is only going to have one such query. But again, there's other keywords like delete, update, insert, and yet others. Select is the operative word here. Here I'm declaring an NS string called SQL. In the next line, I'm dropping back down into C, declaring a statement. And then in this third line, I'm calling SQLite3 underscore prepare underscore v2. This is what happens when you don't really plan your functions ahead. The names get like this. And then I'm passing in a few values, again converting from a Objective-C style object to a C style string. And let me wave my hand at some of the details there. But what this just means is get ready to execute the previously declared query. Select select word from words. So what is words? Words, again, is the database, or specifically it's a table inside of the database, like an Excel spreadsheet. And Word specifically is one such column from that spreadsheet. So this is a super simple database. It essentially is an Excel file with a single column A, if you will. And column A is called, just because I named it such, Word. So it's not even really that interesting of a database. Yeah?
Where does it know from which database to query against? I mean, the table is clear as Word, but normally you also make database.table, right?
Exactly. So you don't strictly need to specify the database name. You don't need to say database.table if it's obvious from the context. And in this case, you can infer it from the context because when we open the connection, we open the connection to a specific database. So that part has already, that question has already been answered for the library. So now down here is where we're actually fetching data. So by calling SQLite3 underscore step, passing in that statement that I've prepared in the previous line, if that equals SQLite row. So in other words, if that function returns to me a row in the form of a structure, I can then proceed to do the following. This next line of code gets the 0th column, or the 0th cell from that 0th column from that returned cell. And then in this next one, I convert the string that I've gotten back to what kind of object? So an NS string. And then in the last line, I'm finally back to more familiar territory. I'm adding that NS string to my property, which is an NS mutable array called words. So again, the difference here for those less familiar with C is that in C, there is no notion of an object. There is no notion of a class. It's not an object-oriented language. So to implement the idea of a string, what C does is it uses an array, so a chunk of memory. And then to represent the string, it uses a \n, a null character at the end of the string. And then it gives to you the address of the first character. So in C, if you know the address of the first character, and you know that there's guaranteed to be a null character at the end of the string, you can figure out how long that string is and what the word being expressed actually is, deer or boar or whatever it is in the database. Objective-C, by contrast, uses classes and objects, so maybe that's how an NS string is implemented underneath the hood. We just don't know. So what these several lines of code are doing ultimately is toggling back between these modes so as to use the C-based SQLite library while still using it in an Objective-C context. And then lastly, we close the database connection. And the rest of the code here, which we won't traipse through in any detail because it's pretty much the same as last week, the rest of the code just has to do with the UI table view and somehow defining the cells that you see when asked what goes at row 0, what goes at row 1, what goes at row 2, and so forth. But there's one thing I had to do behind the scenes. Recall that for quite some time under frameworks, we've had just UIKit.framework, Foundation.framework, Core Graphics.framework, which we finally started using tonight. Notice that in supporting files, there's something similar in spirit, but it's a C library. So it's called a dynamic library. SQLite3.dynlib. This is a file that I did not drag and drop into my project per se. Rather, in order to use this library, and potentially any number of other libraries that Apple provides, I went into my target, went to build phases, went to link binary, And here is where you see the list of libraries that your application is using. By default, we've always gotten those 3 Objective-C libraries. Today, I needed a 4th library, namely the SQLite library. So to get there, I had to click that plus icon and then look through a list of libraries. And you'll see there's an overwhelming number of options, suggestive of just how much more you can do with the environment if you really dive in deeper. This happens to be a C-based library. And what do you think is inside of this library? What is the point of adding this row to this configuration table? I wrote SQLite earlier, right? I wrote the various function calls. Why do I need to add something like this? What must be inside there? What's that? All the function definitions, so the actual implementations. The only thing I had to do, even though we glossed over it earlier, is in my viewcontroller.m file, I did import this .h file. But in a .h file is not the implementation of some function. That typically is in some other file. So if I actually want the bits, the zeros and ones that collectively compose the SQL-like statement query, the close query, the open query, I need to actually import those bits at link time, so to speak, and the means by which you do that in Xcode is via the project's own properties under build phases. So FYI. Yeah?
So most modern languages have at least one, if not 2, wrapper APIs for SQL. So I mean, I don't mean to be lazy, but is there an Objective-C wrapper to do all this stuff?
Short answer, not as cleanly as would be ideal. Rather, there's an even higher layer of abstraction called core data, which is actually a pretty broad topic unto itself, but it's essentially an abstraction layer on top of SQL, or it can be on top of something else potentially, that allows you to define your entities and your relations without going into the depths of SQL. All of that would be generated for you. So short answer, no. No wrapper in Objective-C. Rather, Apple leapfrogged and went one level higher. Quite possibly, yeah. I've not used one, but there's not one that comes out of the box officially. Good question. So wonderfully useful, but also takes some getting used to. So keep that in mind. But much more powerful than something like a single plist file. So let me open up a little teaser here. Some of you may recall, or have at least heard of, a little game that for many years was amazing. And it looked like this. Let me go ahead and run this. I'm going to put the iPhone into a landscape mode this time. And notice that the computer is playing on the left. I, the human, am playing on the right by moving the cursor, or my finger really, up and down. And if I do this, and I can do this all day long, this will just play and play until I do something stupid, whereby if I forget to move, now he has a point. So why don't we go ahead and take our 5-minute break here. And I really lost fast there. Why don't we take our 5-minute break here, and when we come back, we will implement Pong together. All right, so first, let's resume by lowering expectations. This is an example called Paddle, which is among tonight's examples, whose sole purpose in life is to do this. But it's a good building block if we actually want to get to the point of actually having a bit of AI, if you will. You'll notice if you play the Pong game as it's been written, the computer will never, ever, ever lose, because as we'll see, the code is written in such a way that the paddle always moves to precisely where the ball is, no matter where you hit it. So only the human can lose that game. But we'll start by at least making our own paddle here. The cursor there on the screen is what my finger would be if we weren't doing this in the simulator. But first, we need a little bit of context. So let me switch over here for just a moment, just to paint a picture of how your mental model should be when it comes to graphics. So core graphics is the context. We've seen this library included for every example we've done thus far, but this is the first night where we're actually using it. And what's worth keeping in mind, is this system. Got to get better at this. This coordinate system here. So I looked for a newer image, but even Apple's documentation uses like the iPhone 3 for this example. But it's really just to paint a picture of the coordinate system in iOS, which is this plane where you have x coordinates on the right, y coordinates on the vertical. And this is just, the takeaway here is that the coordinate system begins in the top left-hand corner. So 10, 10 means 10 over and 10 down, not the opposite, as you might know from, say, typical Cartesian coordinates in algebra. So The catch is, as Apple's hardware has advanced over time, that resolutions have started to change, right? There was the Retina display in the iPhone 4 when the resolution essentially doubled, and unfortunately this could have broken a whole lot of applications. But Apple actually anticipated something like this in the sense that you don't think of graphics in the two-dimensional world of iOS as pixels, but instead as points. And a point is still just a dot, but it might be 1 pixel, or maybe it's 4 pixels. It depends on your perspective. So they introduced this layer of abstraction called points so that irrespective of the actual resolution, the operating system will double your graphics as needed or shrink them as needed. Now this is a two-edged sword. It's on the one hand super convenient. On the other hand, if you've ever used an iPhone-only application on an iPad, it just looks kind of ridiculous when you zoom in at 2x. But that's really the only other alternative would be not to let the user play it at all. So now if we scroll over to this system here, you'll see the iPhone